So let us recall what is Fourier transform of a function. So Fourier transform of f of x denoted by capital f of x or capital F of omega is equal to 1 by root 2 pi integral minus infinity to infinity f of x e raised to minus I omega x dx. Similarly, its inverse transform is inverse Fourier transform is denoted C is f of x is equal to 1 by root 2 pi integral minus infinity to infinity capital F of omega e raised to I omega x d omega. Okay, so this is Fourier inverse transform, and this is Fourier transform of a function. So let us do few problems. Let us discuss few problems. First one is find find Fourier transform of a function. Fourier transform of a function f of x equal to e raised to x if a less than x less than a and 0 otherwise. The first step is we have to write the Fourier transform formula 1 by root 2 pi integral minus infinity to infinity f of x e raised to minus I omega x dx. So here f of x is e raised to x when x in between a and minus a and 0 otherwise. So what we will do is we just apply here. So f of omega is equal to 1 by root 2 pi integral. So here x ranges from minus a to a and 0 otherwise. So our integral is integral minus a to a e raised to x e raised to minus I omega x dx. Now this is e raised to x e raised to x into e raised to minus I omega x, and we know that e raised to a into e raised to b equal to e raised to a plus b. Similarly, here e raised to x into e raised to minus I omega x, this can be written as 1 by root 2 pi integral minus a to a. Here x is common, so I am taking x outside, 1 minus I omega x dx. And we know that 1 minus I omega is a constant. So while integrating this, we will get 1 by root 2 pi e raised to 1 minus I omega x. Its integral is 1 minus I omega. Ranges from minus a to a. So just applying the limit, you will get. I can take 1 by root 2 pi into 1 minus I omega outside, and I am applying the limit e raised to 1 minus I omega a minus e raised to 1 minus I omega minus a. Here there is minus. So this is the answer. Fourier transform of the particular function. So this is very easy problem. So now next we will do another problem, and this is very important problem. Here we are integrating modulus function. So the second question is find Fourier transform of f of x equal to e raised I e raised to minus mod x, e raised to minus mod x, minus infinity less than x less than infinity. So now f of we are integrating this. F of omega is equal to 1 by root 2 pi integral minus infinity to infinity. Here f of x is e raised to minus mod x into e raised to minus I omega. And we know that the value of mod x is x when if x greater than 0. If x is positive, then value of x is x itself. For example, if you have 7, 7 is greater than 0, then we know that mod 7 is 7. And what will be mod x if x less than 0? What is the value of x? Mod x. Anybody? X less than 0, what is the value of mod x? So mod x, if x less minus x, right? That means if we have minus 0, 7, that is less than 7, then mod of minus 7 is actually minus of minus 7, which is equal to 7. So mod x is equal to x when x greater than or equal to 0 and minus x when x less than 0. Now, okay. Now we will integrate this. So now we will split the integral 1 by root 2 pi integral minus infinity to infinity. You know that e raised to minus mod x is when x less than 0, it is minus of minus x, which is equal to e raised to x. So e raised to x into e raised to minus I omega x plus splitting from integral 0 to infinity. We know that what is e raised to minus mod x? When the x ranges from 0 to infinity, that means x is positive. What is e raised to minus mod x? Here there is minus sign is there. Mod x is when x greater than 0, it is x. So e raised to minus x, e raised to minus I omega x d. Now tell me, so anybody have any doubt? Okay. So now we can integrate this. This is 1 by root 2 pi integral minus infinity to 0. I'm splitting the integral, e raised to x into e raised to minus I omega x is 1 minus I omega x e raised to 1 minus I omega x dx. Integral 0 to infinity, we know that here minus x is common, so I am taking minus x outside, e raised to minus of 1 plus I omega x dx dx. So now we are integrating 1 by root 2 pi e raised to I 1 minus I omega x divided by 1 minus I omega integral minus infinity to 0. Then again this integral is e raised to minus I 1 plus I omega x is e raised to minus of 1 plus I omega x divided by minus of 1 plus I omega x. Okay. Now we will apply the limit and tell me what is okay. So what is e raised to 0? What is the value of e raised to 0? If I am applying the upper limit here, what is the value of e raised to 0? You will get 1 minus I omega into 0, that is e raised to 0. Anybody tell me what is the value of e raised to 0?
1.
1, right? Okay. So it is And what is the value of e raised to minus infinity? If I am applying the limit here, e raised to 1 minus I omega into minus infinity is e raised to minus infinity. So what is the value? E raised to minus infinity?
0.
0. Okay. So you will get 1 minus 0. Similarly, if I am applying here infinity e raised to minus 1 plus I omega infinity, that is minus infinity. So that is 0 minus minus, you will get plus. If I put apply the limit 0, you will get 1. So the answer is 1 by root 2 pi. If I am cross multiply 1 plus I omega plus 1 minus I omega divided by 1 minus I omega, 1 minus I omega into 1 plus I omega, that is 1 square in minus I omega square. So I omega and I omega get cancelled. And what is 1 square minus I omega square? This is 1 plus I omega square. Here there is plus. And root 2 and root 2 get cancelled. So you will get the answers root 2 pi 1 plus omega square. Okay. So now that is the answer. So that is f of omega is equal to root of 2 by pi 1 by 1 plus omega square. So anybody have any doubt? So next we will move to the problem. This is very important problem. If anybody have any doubt, please ask me. Now we have to find the Fourier transform of e raised to minus ax square. So we have already done Fourier sine transform of this. So e raised to minus ax square. So the problem is we cannot integrate this function. So when നമ്മൾ integrate ചെയ്യാൻ പറ്റാത്തപ്പോൾ എന്താ എടുക്കാറുള്ളത്? We cannot integrate the function. We will take a derivative and then we will convert it into a differential equation. And before going to that, what is an even function? So when we say that a function is even, if f of minus x equal to f of x, okay, then we say that a function f of x is even. And also let us recall what is integral minus infinity to infinity f of x dx when f is even function. What is the value? If f of x is even function, and we know that when we say that it's an even function, f of minus x is equal to f of x. Then what is the value if f of x is an even function? Integral minus infinity to infinity f of x dx. Anybody?
2 into integral 0 to
Integral 0 to infinity f of x dx. Similarly, when it is an odd function, we know that f of minus x equal to minus f of x. Then we say that f of x is an odd function. And we know that integral minus infinity to infinity f of x dx equal to 0 when f of x is an odd function. And also let us recall what is an gamma integral. So here we are using gamma integral. And I told you that this type of integral, integral 0 to infinity, e raised to minus x, x raised to n minus 1 dx, This value is gamma n, that is this n. So integral 0 to infinity e raised to minus x raised to n minus 1 dx is gamma n. And also you just note it down, gamma 1 by 2 is root pi, this value. So this you have to remember. And also there are some property like gamma n equal to n minus 1 factorial when n is an integer, or gamma n is equal to n minus 1 into gamma n minus 1, and we have a recurrence formula here. So this is what we call a gamma integral. So let us so now what we will do is we will integrate. We have to find this integral. F of omega is 1 by root 2 pi integral minus infinity to infinity e raised to minus ax square into e raised to minus I omega x dx. Now if we add, you will get e raised to minus x square plus minus I omega x. So you cannot integrate this function. And also we know that what is the value of e raised to minus I omega x by Euler equation? Here I omega is constant. So this is actually cos omega x minus I sin omega x. And we know that cos is an even function and sin is an odd function. So I am converting this in this format. So this is integral 1 by root 2 pi integral minus infinity to infinity e raised to minus ax square cos omega x minus I sin omega x dx. So now we will integrate this. This is equal to, actually I am splitting this integral 1 by root 2 pi integral minus infinity to infinity e raised to minus x square cos omega x dx plus minus 1 by root 2 pi I minus I integral minus infinity to infinity e raised to minus x square sin omega x dx. And you know that f of x is equal to e raised to minus ax square. This is it an even function or odd function? Here there is x square term. Is it an even or odd function? Then the function if I am putting f of minus x, I will get e raised to minus a minus x whole square. So this is equal to e raised to minus ax square. This is f of x. So this is an even function, right? E raised to minus ax square is an even function. And also this is even and this is even. Cos omega x is even. So totally this will be an even function. Similarly, e raised to minus ax square, this is odd, even, and sin omega x is odd. Therefore, even into odd is odd function. So this is completely odd function, and this integral is 0. And again, this integral become is equal to 2 by 2 times 0 to infinity. So this is 2 by root 2 pi integral 0 to infinity e raised to minus a x square cos omega x dx. Okay. So So now our integral f of omega is converted into this format. So f of omega is this. Okay. Now we have to integrate this. So again, the problem is we cannot integrate this function because e raised to minus ax square is there. So now what we will do is we will find the derivative f dash of omega. We are differentiating with respect to omega. Omega we will get, that is df of omega divided by d omega equal to, you can write 2 by root 2, this is root 2, root 2 by pi integral 0 to infinity e raised to minus ax square sin omega x d omega. Derivative with respect to omega is minus sin omega x into x. And this is equal to square root of 2 by pi 0 to infinity sin omega x. And I am rewriting this. First term as sin omega x into, here x and minus n is minus x into e raised to minus ax square. And we know that integral minus 2ax e raised to minus ax square dx is e raised to minus ax square, because derivative of this is the integrand of this integral. So for that I want here e minus 2a, so I am multiplying with the 1 by 2a here, integral 0 to infinity sin omega x minus 2ax e raised to minus ax square. Now we are integrating on both, integral u v dx. We know that u into integral v minus u dash into integral v. So like that, I am writing 1 by 2a root 2 by pi u. Here u is sin omega x into integral minus 2a x e raised to minus x square. That integral is e raised to minus x square 0 to infinity minus sin omega x. This derivative is omega cos omega x, and this integral is e raised to minus ax square dx. Now I am applying the limit, 1 by 2a root 2 by pi. I am taking mine. Okay, if I am applying the limit here, my infinity, then you will get e raised to minus infinity, that is 0, and I am applying the limit 0, then we know that sin 0 is 0, so this completely get cancelled, and I can take minus omega here outside. So I am taking minus omega outside, integral 0 to infinity e raised to minus ax square cos omega x dx, and this is equal to uh, so this value, okay, this value is equal to, I am taking minus omega by 2a in root this value root 2 by pi integral 0 to infinity e raised to minus x square cos omega x dx. This is actually equal to f of omega. So I can write this as f of omega. So I am getting um, a differential equation of the form d of f omega is equal to minus omega 2a f of omega. So that is d by d omega f of omega is equal to minus omega by 2a f of omega. That is 1 by f of omega d f of omega is equal to minus omega by 2a d omega. So if I am integrating on both sides, 1 by f of omega d f of omega is log f of omega. You know that 1 by integral 1 by x dx is log x. So here integral 1 by f of omega into d f of omega is log f of omega, and this integral is minus omega square by 4 plus a constant. You know that if we are integrating, there is an integral constant. So I'm taking it as log a for making the calculation much easier. So I'm taking log a on the other side. Log f of omega minus log a is equal to minus omega square by a, and we know that log a minus log b is equal to log a by b. So here log f of omega minus log a is equal to log of f of omega by a is equal to minus omega square 4a. Now if I am taking the exponential on both sides, we will get f of omega divided by a is equal to e raised to minus omega square by 4a. So this is equal to f of omega is equal to a times e raised to minus omega square by 4a. Okay. Now the only unknown is a. If I know what is a, then we will get a Fourier transform. So in order to find a, if I put omega is equal to 0 in this equation, I'm calling in this equation, I will get a into e raised to 0, that is a. So f of omega is equal to a. Similarly, and we know that f of omega from the starting, it is root 2 by pi integral 0 to infinity e raised to minus x square cos omega x dx. So if I am putting omega is equal to 0 here, we know that cos 0 is 1. So I will get this. So what is the value of f of 0? F of omega at a equal to 0. So this integral is equal to a, root 2 by pi integral 0. So in order to find this integral, we will use gamma integral. Okay. So in order to change, and I already told you that integral 0 to infinity e raised to minus x raised to n minus 1 dx is equal to gamma n. So I have to convert this integral into gamma integral. So for that, here there is minus ax square. So I am putting ax square is equal to t. Then taking derivative 2ax dx is equal to dt. Therefore, dx is equal to dt by 2ax, which is equal to dt by 2ax. 2ax you can written as 2a into x. X is actually root t by root t by root a. Root t by root a. So that is equal to root 2 into root a root t. So that is equal to f of omega is equal to, at omega is equal to 0, integral 0 to infinity e raised to minus t into dt by 2 root a root t, which is equal to 1 by root 2 pi 1 into 1 by root a e integral 0 to infinity e raised to minus t. T raised to 1 by 2 you can written as t raised to minus 1 by 2 you can written as t raised to 1 by 2 minus 1. So here instead of, this is in the gamma integral, and here instead of x we have t raised to 1 by 2 minus 1. So this integral value is 1 by root 2 pi into 1 by root a into, this is gamma instead of n here 1 by 2. So gamma 1 by 2, and we know that gamma 1 by 2 is root pi. So this is 1 by root 2 pi 1 by root a root pi. Root pi and root pi get cancelled. You will get 1 by root 2a. So so we get a is equal to 1 by root 2a. Now f of omega is equal to a 1 by root 2a equal to e raised to minus omega square by 4. So this is the final answer. Anybody have any doubt? എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടെങ്കിൽ ചോദിച്ചു. So now what I will do is I will define one property. Okay. So by using a property, we can do a problem. So that problem. Now Fourier transform of derivatives. Fourier transform of derivative. So so this is if f of x be continuous on x axis, then the Fourier transform of f dash of x is equal to I omega Fourier transform of f of x. That is equal to I omega f of omega. So note it down. This is a formula. Fourier transform of f dash of x is I times Fourier transform of f of x. So this is a formula. Similarly, Fourier transform of f double dash of x is equal to minus omega square Fourier transform of f of x. So now in order to do this problem, find the Fourier transform of x into e raised to minus x square. Now we know that Fourier transform of if f of x is equal to e raised to minus ax square, then we have Fourier transform of e raised to minus ax square is this 1 by root 2 a e raised to minus omega square by 4. Now, if a equal to 1, then we have f of x is equal to, if f of x equal to e raised to minus x square, ഇവിടെ a 1 ആണെങ്കിൽ a is a constant, then you can write that f of omega is here a equal to 1 by root 2 e raised to minus omega square by 4. And we know this. Okay. Now, and also we have linearity property. Linearity property, that is Fourier transform of f of x a into f of x plus b into g of x is equal to a times Fourier transform of f of x plus b times Fourier transform of g of x. So if a and b are constant, a and b are constants, you can take constant outside. Okay, so that is Fourier transform of a into f of x plus b into g of x is equal to a times Fourier transform of f of x plus b times Fourier transform of g of x. So f of now I can write f of x into e raised to minus x square is actually, this is x into e raised to minus x square is actually derivative of minus 1 by 2 e raised to x square, right? That is minus 1 by 2 e raised to x square. Its derivative is x into e raised to minus x square. So now what we will do is, so we have x into e raised to minus x square is actually minus 1 by 2 times e raised to x square derivative. Its derivative, this function. And we know that Fourier transform of f dash of x is I omega times Fourier transform of f of x. So I can take minus 1 by 2 outside, then f of e raised to minus x square, this derivative is equal to minus 1 by 2 times I omega Fourier transform of e raised to minus x square. And we already know that Fourier transform of e raised to minus x square, that is 1 by root 2 e raised to minus omega square by 4. So I can write minus 1 by 2 I omega Fourier transform of this, and if I write together, you will get 1 I minus I omega divided by 2 root 2 e raised to minus omega. Now I will define, and there are few problems. Okay. Now last, I will just give a definition of convolution theorem. We doesn't want to do any problem using convolution theorem of Fourier transform. Convolution theorem. So you have to study this statement. So statement, you note down this statement. Suppose that f of x and g of x are piecewise continuous, bounded, and absolutely integrable. Piecewise continuous, bounded, and absolutely integrable. On the x-axis. You have to study this statement. Okay, on the x-axis, that is f of x is and g of x are piecewise continuous, bounded, and absolutely integrable on the x-axis. then Fourier transform of convolution f star g is equal to root 2 pi Fourier transform of f into Fourier transform of g. And we will study convolution in next chapter. What is f star g? Okay, we will study this what is f star g of t in next module, Laplace transform. So you have to study this statement. Okay, so